Whew. All right, let's take a break. Let's look at chat. Anything going on there? He is awk to a professional. Bro, it's not what I expected to see when I looked down in chat. Oh my god, get out of here. So we're going to do Advent of Code in Bash, and we're going to start with day one. I haven't looked at day one yet. As you can see, we're already a couple days into this. I have no desire to get points on the leaderboard or anything like that. I just want to do this for fun and as a learning experience and just for the the heck of it, writing it in Bash. I'm going to try and do it in pure Bash, meaning I'm not going to fork external utilities when I don't need them, but I'm not going to stop myself from doing that. So if we need to pipe something to sort or set or awk, I'll do it, but I'll do it sparingly. But my goal is to do as much of it in Bash as I possibly can. So let's take a look at this. Let's pull up challenge number 1. Oh boy. Day 1, Historian Hysteria. The chief historian is always present for the big Christmas sleigh launch, but nobody has seen him in months. Last anyone heard, he was visiting locations that are historically significant to the North Pole. A group of senior historians has asked you to accompany them as they check the places they think he was most likely to visit. Interesting, this is cool. As each location is checked, they will mark it in their list with a star. They figure the chief historian must be in one of the first 50 places they'll look. So in order to save Christmas, you need to help them get 50 stars on their list before Santa takes off on December 25th. Oh, this is cute. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Oh, okay, that's interesting. Each puzzle grants 1 star. Good luck. Cool. You haven't even left yet, and the group of elvish senior historians has already had a problem. Their list of locations to check is currently empty. Eventually, someone decides the best place to check first would be the chief historian's office. Makes sense? Upon pouring into the office, everyone confirms that the chief historian is indeed nowhere to be found. Instead, the elves discover an assortment of notes and lists of historically significant locations. How convenient. This seems to be the planning the chief historian was doing before he left. Perhaps these notes can be used to determine which locations to search. Throughout the chief's office, the historically significant locations are listed not by name, but by a unique number called the location ID. To make sure they don't miss anything, the historians split into 2 groups, each searching the office and trying to create their own complete list of location IDs. There's just one problem. By holding the 2 lists up side by side, your puzzle input, it quickly becomes clear that the lists aren't very similar. Maybe you can help the historians reconcile their lists. For example, okay, and this is just example, 3, 4, 4, 3, 2, 5, whatever. Cool. Maybe the lists are only off by a small amount. To find out, pair up the numbers and measure how far apart they are. Pair up the smallest number in the left list with the smallest number in the right list. Okay. Then the second smallest number in the left list, okay, gotcha. Within each pair, figure out how far apart the 2 numbers are. You'll need to add up all of those distances. Oh, okay. So take the difference of these 2 numbers, 3 and 4, and the distance is 1. The distance is 1. The distance is 3. The distance is 2. Okay, and then add those numbers for a final sum. Okay. For example, if you, I should have just read this. Okay, so they just go on to do what I'm doing here. Yeah, for example, if you pair up 3 from the list with a 7 from the right list, the distance is 4. If you pair up a 9 with a 3, the distance is 6. Okay, so take the difference in absolute value. Got it. In the example list above, the pairs and distances would be as follows. The smallest number in the left list is 1, and the smallest number in the right list is 3. The distance between them is 2. Okay, so this just shows for everything in that input. To find the total distance between the left list and the right list, add up the distances between all the pairs in the example, and this is 2 plus 1, blah, 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 total distance of 11. Okay, your actual left and right lists contain many locations IDs. What is the total distance between your lists? Okay, to begin, get your puzzle input. Probably can curl it, right? Let's try and curl this and put it into input.txt. So if we had input, oh, I see. Puzzle input differs by user. That is cute. That's nice that they put that message there. So there's some sort of key or whatever I'm getting with the puzzle input. Let's go ahead and fire back up the terminal. And if we do a head on the input, you can see that I have a whole bunch of data over here. Now, before we even try to do this, let's just work with this because we know that this example, I'm going to use the example input they gave us. So we'll do a vim example input.txt. We know that with the example input.txt, we should have a distance of, what do they say? 11. So let's do calculate distance. We'll call this script. And then we'll do user bin and bash. Okay, people are saying they can see that. See it, that's great. All right, so we're gonna write a script called calculate distance. So we are going to read in the data, and the data is 2 columns, as you can see, a number and a number. We have to go through, we have to get the smallest on the left, the smallest on the right. Okay, let's just read those 2 numbers in. While read -r num1, num2, do, done, echo, num1, and num2. Cool. So now if we cat the example input into calculate distance, we get this. So we're just looping through the list and we have both the numbers there. So we are good. That increased the font size by 25 to 40%. I can increase it a little bit. I do feel like it should be like just slightly bigger. Cool, cool, cool. I'm watching on the refrigerator, by the way. I hate you. So if we do calculate distance and we take in the example input, oh, this prompt is gnarly. How about we do this? PS1. There we go. Let's lower the prompt. Okay. So there we go. Cool. So calculate distance. So we have to get all of the first numbers and all the first and all the second numbers. So we'll do left-hand side, we'll make a new array, and right-hand side, we'll make a new array. So we'll get all the numbers on the left and all the numbers on the right. So left-hand side, wait, what is this indentation? Why am I indenting by 4 spaces? Yeah, no. Let's indent these by tabs. I'm a hard tabs, 8 spaces per tab kind of guy. That looks better. Left-hand side plus equals num1. Right-hand side plus equals num2. And now we should have an array of all of the left-hand side numbers and all of the right-hand side numbers. So let's look at the left-hand side numbers first, just to verify that we did this. Hey, there's the first list of numbers. So if we cat the example input and we just grab the first field, that should line up, yeah. 342133, 342133. That lines up. For anyone watching who's wondering what my field command is, that is literally just that's just a little awk thing that I wrote a million years ago, which is just basically doing this. Like we're just printing $1. That's all I'm basically doing there. Okay, so we have a left-hand side, we have a right-hand side. They are unsorted, but we will have to sort them. I don't have any sort of built-in sorting mechanism for arrays in Bash. There is one, but it's a loadable plugin, and my version of Bash did not come with it compiled in, so we're going to use the sort utility to knock this out, right? So we'll set, what's a good way to do this? I think we can do printf. Let me do some testing here. I think we can do this. And this will separate. So this, for an example, this will print all of the left-hand side separated by new lines. Cool. So now that we have that, we can just pipe that into sort. And there we go. We'll have the left-hand side separated by new lines. Am I missing something? Doesn't look very... Oh, I'm doing field 1. Yeah, I'm stupid. Pipe that into calculate. There we go. That's sorted from smallest to largest. Now we'd probably have to read that back into an array. I'm trying to think. There's a couple ways to do this. I think we could actually just use like read array, right? Read lines from a file into an array variable. Yeah, I think we can just use read array, a synonym for map file. Yeah, that makes sense. I think we can do this. And let me double check. Let's mess around here. I think we can do read array left sorted, and then we can read in from this, right? And if that works, we can just print left sorted. That looks good, except there's still some white space being pulled in there. I think that's a map file thing. I think you have to give it a -t, right? Yeah. Yep. I really used read array. Why not just use map file -t? There we go. There we go. Look at that. There's an array sorted from smallest to last. Yeah, read array is super cool. It's a built-in method to Bash. And if you look at the help message for it, you can see that it's just a synonym for map file. Map file is super cool. It allows you to, it's not like mapping a file. It's different than that. but it allows you to read from standard input and then read it into an indexed array variable. So we can take standard in from something and then put it into an array in Bash, which is super useful. I'm trying to think if there's a cleaner way to do this, to take an array, separate it by new lines, and then sort it. I think this is probably the cleanest way to do it. We can just do this now. Right sorted. And then we just change this to right-hand side. And then... Cool. Cool. So there are the two lists from smallest to largest, which is exactly what we want. And now we need to calculate the distance between them. So we have to loop over them. We can loop over one or the other. It really doesn't matter. We should probably just get the length of one of them. They should be the same, but we should get the length of one of them. We could probably put an assert saying, hey, there's something wrong if they're not the same. But let's assume that the input is good for now on. So we'll say len equals, we'll get the length of the, and we can just use left-hand side here. It doesn't matter if they're sorted or not. There we go. So we got the length of that. Now we can do a for I equals 0, I less than len I plus plus. Done. We can do left equals left sorted, and then we index it based on I. We can do right equals right sorted, index based on I, and now we should have the left and right variable. So if we do this, and we just print them out to the screen, there we go. We have the numbers that we need to calculate the distance between. So it's the left-hand side and the right-hand side. They're both in ascending order, which is really good. So now we have to calculate the distance. To calculate the distance, we just need to subtract one from the other. So let's do this. Let's do diff, because it's the difference. We'll do left minus right. It doesn't matter which one we do. There's a chance that this will come out as being negative because we're calculating a we want the distance, not the difference, but we're calculating the difference. So yeah, we have some negative values here. So what we can do, there's a couple things we can do. There's two things we can do here. We can do a proper math way of doing absolute value where we can check, oh, is the number less than 0? Then we should multiply it by -1. That's a really simple way to do it. But we're in Bash, so we can just chop off the hyphen character if there is one. So let's just do this. I'm going to comment it because it might be kind of weird. Diff equals diff # hyphen. So this will remove the hyphen at the beginning of the string if there is one and do nothing if there isn't one. So now we can save this as dist because it's distance, not difference. So there we go. There's the distance of all of them. And this lines up. So if we add all these together, according to the original advent of code, this should be 11. So let's create an accumulator here, which will just start adding things up as we go. And then now that we're down here, we can say accum plus equal dist. So we're adding the distance to the accumulator, which we start at 0. And then we will just echo accum here. And we'll say something like, I don't know, final total equals this. And if all this is right, this should just work. So this should give us, let me check the Safari page real quick. So if we go over here, when we add up all these numbers, we should get the total distance of 11. Cool. So let's go ahead and run this and see if we get 11. And we do. Hey, look, so our code works. So now, what I'm going to do is I'm going to use the example input. We used example input. Now I'm going to use the real input. Let's move input to, what should we call it? Part 01 real input.text. Let's cat part 01 real input.text and pipe it into calculate distance. And if this works, I should get a really, really big number. All right, here we go. Moment of truth. Let's run this. And hey, we get a really, really large number. So now let's copy this. And if I submit my answer, is this something I can screen share? I assume, right? Because right here, it just asks me to screen share this. And let's hit submit. That's right. You are 1 gold star closer to finding the chief historian. Hey, look at that. We nailed it. How awesome is that? Let's continue to part 2. Oh, that's beautiful. Cool. This is super fun. This is such a neat little challenge. Your analysis only confirmed what everyone feared. The two lists of location IDs are indeed very different. Or are they? The historians can't agree on which group made the mistakes or how to read most of the chief's handwriting. But in the commotion, you notice an interesting detail. A lot of location IDs appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. That's interesting. This time, you'll need to figure out exactly how often each number from the left list appears in the right list. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times that the number appears in the right list. This is so interesting. I like the way they make you get answers in this, because the answers end up having to sum a lot of data and then get like an arbitrarily large number. And it's kind of a good way to prove that, like, hey, you got it. Because otherwise you'd be way off in the weeds if your answer was wrong. That's a cool way of doing it. Here are the same example lists again. Cool. Here's the process of finding the similarity score. The first number in the left list is 3. It appears in the right list 3 times. Oh, okay. I see. So the similarity score increases by 3 times 3 equals 9. So we'll need another accumulator. Okay. The second number in the left list is 4. It appears in the right list once. So the similarity score increases by 1. Oh, okay. Third number is 2. Okay, so you multiply it by the number of times it appears in... You go through left-hand side, multiply it by the number of time it appears in right-hand side, and then you add those all up to some sort of total accumulator thing. Cool. Okay, so the puzzle input is exactly the same. This is awesome. You guys ready for this? Let's figure out how to do this. So the first thing I'm going to do is I'm going to take calculate distance, and we're going to CP it to calculate similarity score. So now we have a second script. Let's go ahead and vim that. We read in the left-hand side, we read in the right-hand side. We sort them, which I don't think we do here. We don't need to sort them. Yeah, because the sorting won't actually matter. So let's not sort them. And so what we need to do here is we need to make not a set. It's sort of like a dictionary. We're going to make an associative array for the right-hand side data. So the right-hand side data, I realize I'm not sharing my terminal. Thank you. Yeah, my bad. Yeah, appreciate it. I will share my terminal, don't worry. So we're going to make an associative array to store these right-hand sides. And browser's off. Okay, sorry. I'll go back and show you guys what I did. In fact, I'll just redo it. I'll redo it. Let me CP calculate distance over to calculate similarity score. And there we go. I've wiped out any changes I've done where I wasn't sharing. So now we will do this from the top. Calculate similarity score. Hey, here we go. Let's see. So right here, we sort the data, but we don't actually need to sort it for this second problem. So I'm going to get rid of the sorting logic. And then I'm going to go over here and let's not even loop. We have an accumulator here, plus equal something, but let's not even worry about it. The important information is going to go somewhere in here. So the first thing we're going to do is we're going to loop through the right-hand side of the data, and we're going to create an associative array. So I'll show you guys what this will look like, not in bash terms. It's going to be like JSON. So it's not valid bash, but I'm just explaining the idea here. So if the right-hand side had the number 4, and let's say that number showed up 7 times, the data would look like this. If it had the number 0 and that showed up 2 times, it would look like this, and so on. So we're going to create this data structure in bash where I go through the right-hand side and count how many times each number has showed up. So in order to do this, we need to loop the right-hand side. First thing we need to do is create an associative array. There we go. And we'll call this right-hand side count, because that's for counting how many times things show up on the right-hand side. Now we're going to loop every value in the right-hand side. So for value in right-hand side, we're going to use this notation to loop through every item of the array. And then what we're going to do is we're going to increment the number that is in the associative array. If you've ever used Python, you might have heard of something called like default dict, which is the default dictionary where you can set a dictionary to automatically have a default value when you reference a key for the first time, which allows you to kind of really simply do these like frequency counts. You kind of get that in bash for free. The value kind of acts like 0 if it's unset. So I can do RHS count value plus plus. And in order for this to work as math, I need to put it in open and close double parentheses. So this will index the array by the value and then increment it. So at the end of this, we will have a count of how many times these things show up. So now we can loop the left side. So instead of looping the right side, we're going to loop the left side. And we'll keep our accumulator value of 0. This is going to add up to be the final result. For value in left-hand side, what we need to do is find out how many times it shows up in the RHS count. So we'll call it frequency. Frequency equals RHS. We'll index it by value. And there we go. So now we have the value itself, the frequency. So we can say result equals value times frequency, and then accumulator plus equal result. There we go. I'll just comment this. Read the data into two arrays. Get frequency count for right-hand side values. Loop left-hand side values and calculate totals. And then final score equals the accumulator. So let's go ahead and run this and see if it works. Let's not CP over. That would be really bad. Cat example input and pipe it to calculate similarity score. So according to the browser, I will pull this back up and I won't forget that I pulled it up. We can see for the examples here, we should have a total number of 31. So if we run this, we should see 31. 76. That doesn't look right, does it? That's awesome. Cool. You know what? I'm actually glad something broke because now we can debug it, and that's kind of a fun thing to do. So let's go ahead and echo value equals value. Let's do it down here. Value equals value. Frequency equals frequency. And let's see if there's any obvious outliers for this. So value equals 3, frequency equals 3, value equals 4, frequency equals 9. Okay. I don't think that it showed up 9 times, did it? Something seems right. Or something seems wrong here. For value in RHS on the right-hand side, we increment how many times we've kept track of it. What am I doing wrong here? For the first value of 3, it should be 9, and we're getting a frequency of 3. Okay, so result is being set to the exact frequency, which seems wrong. And these frequency values seem wrong too, don't they? So I'm doing something incorrect here. I'm going to go ahead and I'm going to hide the chat right now because I don't actually want to cheat on this. I don't want people to give me any sort of clues. I want to figure this out, what's going on here. Because I must be doing something really, really silly here. So let's go through this. Let's go through the example input. So for the number 3 shows up. That is, my terminal just grew sideways when I double click that. I didn't even know Mac did that. That is horrendous what just happened there. Oh, I'm sorry for anyone who had to see that. It just slid across my screen. That was horrendous. All right, so for value 3, it is here 1, 2, 3 times. It should have a frequency of 3, which it does. And the result should be 3 times 3, which is 9. Yeah, see, that's wrong. Why is that wrong? Result equals value times frequency. Oh, I'm printing it wrong. Okay. It's just me. I'm debugging it incorrectly. So that's nicer that that's the case. That was just a stupid mistake on my part. Okay, so the frequency is 9. Okay. Value 4 is a frequency of 9. Okay, that is clearly incorrect. Value 4 does not show up 9 times. In fact, I think value 4 shows up 0 times. So it should have a frequency of 0, not 9. Where do we get 9 from? I'm curious. What we can do is we can print this variable, RHS count, and we can see what's going on here. For key in RHS count. I have to put an exclamation mark here so it actually knows we want the keys. Do echo key equal value. Done. Put a $sign here, and then we actually have to get the value out of it. So value equals RHS count key. And let's just exit here. So what this will do is just print out what my frequency count looks like. 9 shows up once, 5 shows up once, 4 shows up once, and 3 shows up 3 times. Is that right? No, 4 should show up 0 times. 2 should show up 0 times. What am I doing wrong here? I'm doing something wrong. The only thing I can think of is if it doesn't show up. Let's see. I'm doing something wrong. Yeah, we're counting how many times the things show up there. Okay, let's take a look. 9 shows up once. Okay, 9 is here once. 5 shows up once. 5 is here once. 4 shows up once. Okay, 4 is here. I'm just blind. 3 shows up 3 times. 3, 2, 1. All right, cool. So let's go back to the similarity score. And these frequencies look right. But for some reason, when we try to index 4, we get 9 as opposed to 1. Where are we getting 9 from? So let's go ahead and trash this because we know that works. This shouldn't change, but let's just go ahead and put that there. And let's run it. 3. Value of 3, frequency of 3, result is 9. Value of 4 has a frequency of 9. See, that's just incorrect. Why does that have that? Yeah, see, look at that. And somehow getting a frequency of 9. Where am I getting 9 from? Am I doing this like backwards somehow? When I figure out what's going on here, it's going to be really dumb and I'm going to be like, oh, I'm an idiot. I can see the future and that's what's going to happen. All right, let's go through it again. Left-hand side, right-hand side, read the 2 numbers in, save the left-hand side to num1. Yep. Okay, so we have a right-hand side, we have a left-hand side. Now we loop over every number in the right-hand side and we set RHS count. Oh my God. Ready? Ready? Remember how I said it's going to be something stupid? Remember how I said it's going to be something stupid? RHS count is the thing that has our frequency in it. RHS count. RHS count. I was indexing the original array, which would have some numbers sometimes. All right. So now let's go ahead and run this. And if this works how I think it should, then we should print the final score of 31, which the original input says. So let's go ahead and get 31. Told you. I told you it would be something stupid. I've done this so many times. Oh, look at this. This is interesting. The frequency is actually empty, but luckily it interpreted empty as like no number. So that worked out really nice that it happened to do that. We could have set it to like 0 in the case that it was empty, but yeah, this seemed to just work out just fine. So we should be able to take the real input and pipe it to calculate similarity score. Ah, it's going to print so much. Let me go ahead and just remove the debug printing. And we'll just get the accumulator value. Oh, wrong input. Cool. There we go. We got the final score here. So let's go ahead and pull back open the browser. And here we go. So let's go ahead and paste this and hit submit. Let's see what happens. That's the right answer. You are 1 gold star closer to finding the chief historian. You have completed day 1. You can share this victory or return to your advent calendar. Nailed it. Day 1 done. Congratulations, everybody. Congratulations myself. We nailed day 1, and all we had to do was fork out to sort. I think that might have been the only external command we needed, and that was in calculate distance, I believe. We had to fork out to sort. Yeah, other than that, everything else was done in pure bash. So, yeah. We did it. Ha ha ha.